we're going to do our day 3 notes. They're super short, and we're going to do the day 3 assignment all in one. Right? And I'm going to take some of the questions off the day 3 assignment. All right. And now I think day 3 is probably one of the most important lessons of this chapter, as in the one you're going to use the most in your future science classes. Right? In your future math classes. Mainly in your future science classes starting next year. So in day 3, we're going to talk about, remember all the 3 different concepts we need to know, graphing, data, and equation. In day 3, we're going to talk about how do you have a graph and create the equation. All right, we're going to talk about this connection right there. Right? Because that's what happens in science a lot of times. Is you do an experiment, you collect all your data on a table, then you graph it, and you have to come up with a relationship. You have to come up with an equation from a graph. Right? So that equation is going to be a line. You got to learn how to do that. That's going to get used so much in your future grade 10, grade 11, grade 12 science classes. A lot. Right? Now, if you look at where equations are, there's 2 paths to get to equations. You can go the long way around. You can take a graph, make a table, like we did in day 2, and look at the table, and look at the pattern inside the tables, and come up with the equation. That's a lot of work, and it doesn't really work out too well with real-life data. Because in real-life data, a lot of the numbers are decimals, and it's hard to spot the pattern. In grade 9, a lot of the numbers are nice whole numbers, or going up by a half, so it's easier to spot the pattern, just getting used to the ideas, but it's not very practical. The practical method is to skip that table altogether. And that's what we're going to do today. We're going to skip that table altogether. And we're going to go, how do you jump from the graph straight to the equation? Okay? And remember what the equation looked like. The equation looked like this. Y is equal to mx plus b. How do you create this thing? All right? All right. Let's get started. We're looking at day 3. So we're going to skip over a lot of the pages of day 3. I feel like we don't really need it. So the first couple pages is talking about the long way around that rectangle. How do you take a graph, make a table, then you make that table, and you make an equation, just like we did in day 2. Right? We had these tables, we made the equation. Right? That's not the practical method. The practical method is you have a graph. How do you know what the relationship, what is the equation for this graph? Right? To do that, our equation here, mx plus b, these 2 numbers that we come up with, the m number and the b number that we come up with, are 2 different properties of a line. They kind of influence how a line looks. So if you can look at a picture of a line and spot those properties, you can create the equation. So once you get really good at this, you can come up with equations of a line like under 10 seconds. Right? It's that quick. So I'm going to show you a bunch of graphs, and I'm going to see if you guys can figure out what these 2 properties are. Right? So first graph I'm going to show you. It's not on your page. It's up on here on my screen. It looks like this. Let's go here and right here. So this is the first graph I'm going to show you of a line. And all I'm going to do is I'm going to change that b value. Right now it's set at 1. I'm going to make it bigger. I'm going to make it to 2. Then I'm going to make it to 3. You notice what happens to the graph. And if you can spot what happens to the graph, we can maybe figure out what the property is. So I'm going to bump it up. And I'm bump it up again. So all I did is I kept the m value the same. And all I did is increase that b value. Made it bigger and bigger. And it went from the red line to the blue line to the green line. What did you notice about the graph? Sorry, I thought I heard somebody say it. The line went up. So this is the exact same line. It can just moved up. That b value right here is called the y-intercept, where our line crosses the y. It crossed right here at 1. Then I made it bigger, and it moved up. So it crossed the y at a higher spot. Then I made it even bigger, and it crossed the y at an even higher spot. So that b value, you can just read right off the graph. It's where your line crosses the y. So I'm going to go back to our notes here and write that down. So we have this b value here. And where's my notes? Where's my pen? There, here. This b value is called our y-intercept. Right? intercept. And intercept is a very long word, and often we get shortened in math class. You don't write it the whole word. You just go y-int, and then like that. That means intercept, right? To shorten that phrasing, so you don't have to write the whole thing down. But the first time we'll do that. So remember, this is where the line crosses the y-axis. That's not too bad. That's easy to spot. You can put a finger on the graph where it crosses, and you just got to read that value, right? Right? So I'll let you write that down. Then, next thing I'm going to do is I'm going to change that m value, make it bigger. And you notice what's happening to the graph there. So you can figure out what that property does. So there's two properties of the line. One is where it crosses the y-axis. And we're going to figure out the second property now. I'll grab back onto my graph so I can get rid of these ones here. So all I'm going to do is I have the exact same line, and I'll make that m value bigger. So this red line stays the same, and I should make the m value slightly bigger. And that's what happens to the line. And I'm going to make the m value even bigger, and that's what happens to the line. And what do you notice? What happened to from the red line to the green line to the purple line? What do you notice with that line? How is it changing? It got higher, right? So it got the technical phrase for that angle getting higher is the steepness change. And the word steepness in math is called slope, right? So the m value controls the steepness, and that's called our slope. So the m value here is called our slope, right? You can think of it like a mountainside, right? Slope, uphill, downhill, that kind of stuff. So this is your steepness of the line. Steepness, right? So slope is the common word. Now, at the beginning of the chapter, I used the words coefficient and constant for this m and b. Those aren't the words we use for lines. Those are the generic words we use for polynomials, because this is a polynomial. But for an equation of a line that always looks like this, so we have specific names. So the b is called the y-intercept. That describes this property. The m is not called the coefficient. It's called your slope. So it describes the steepness. Describes the property, right? Now in science class, in occasional math class, there is another word for m as well. And that is called the rate, right? Means often one of the questions we have is, hey, we do this change to our lab. How did it affect the rate? Did the rate get faster? Did the reaction go faster? Did the reaction go slower? Yeah.
Wait, what does it say for
which one? Which color I'm looking at?
intercept?
Y-intercept,
Yeah.
where the line crosses the y-axis, right? So often in science classes, we want to control how fast things happen. You usually want, sometimes you want to make reactions go faster because you're in a hurry, or sometimes you want to slow things down. So for example, we don't want food to spoil. We want to slow that reaction down. So that's the steepness of the line, right? And that's what you want to kind of figure out. So, okay, m is your y-intercept. Sorry, m is your slope, and b is your y-intercept. So we're using those properties. We have three graphs here, and we're going to come up with the equation of the line, right? So I'm going to write out the equation of the line here. Y is equal to mx plus b. We need to figure out these two numbers. We have the b and the m. Maybe I should use the same colors. Purple and blue, green. Purple and green. Okay, purple, green. Right? We need to figure out these two values. Usually, the y-intercept is the easier one to figure out. On this graph, where does our line cross the y-axis? Here's a line, here's the y-axis. It crosses right there. What number is that? 4. Right? So we write down 4. Means it crosses right here. That's at the number 4. Now, sometimes the line crosses up here. Sometimes it may cross in negative territory. So we have to write down the sign with it too. Is it +4? But sometimes it could be maybe a -4 if it crossed way down here. So we need the sign, whether it's positive or negative. Right? That's easy enough. So we've got our y-intercept. You've got half the marks right there for the equation. There's 2 numbers you have to figure out. You figured out one of the 2 already. So you got half the marks that quickly. The second, the M is your slope, your steepness. We described what the property is, but I didn't just tell you how to figure out what the steepness of a line is. Right? And this one requires a little bit more work. Right? So what we are going to do is make a little ramp, picture of a ramp, a little triangle on our line. So what we need to do is find 2 spots on this line, anywhere on this line, but we're going to be strategic. We're going to pick spots where the numbers are easy to read, where lines cross nicely. So for example, I'm going to look at this and go, hey, here's the line. The lines cross nicely right here. I'm going to have to read values, so I'm going to pick this as one of my spots. Right? And then I look up and down this line and go, is there another spot where the lines cross nicely? Right? Sorry, Reese? Where?
At the top right.
Top right. Oh, right about there. Right? Now, this part right here is probably where students get most frustrated. And it's like, how do I know which one to pick? And the honest answer is, there's lots that work. These are just 2 of the things that work. For example, I could have picked this one if I want to do. That's at 2, and that's at the number 8. Or I could have picked right here. That's at the number 7, and that's at number 18. Right? There's lots of things that work. You just want to pick 2 that works. I wouldn't want to pick something like this right there. Right? It's in between 2 lines, and then I have to guess at what number it's at. And that you're allowed to do it, but then you have to guess. Then you get estimations, so you're doing decimals, and your answer isn't as accurate. So for the purposes of grade 9 and grade 10, there will always be 2 spots on the line where things cross very nicely. Okay, so we got these 2 dots. Right? With these 2 dots, we're going to make a triangle. With the first dot, you're going to go out like this, all the way out. With the other dot, you're going to drop a line down, and you make yourself a little triangle. That looks like a ramp, right? I like shading it in. You don't have to shade it in. I like shading it in. You don't have to. So I'm going to shade this thing in, right? I like to shade it in, right? So with this triangle that you've made, you have to figure out how long are the lines. The up, down line and the left and right line. You have to figure out how long those 2 lines are. So let's do this line here first. The one that goes from here to here. How long is this bottom line? Well, we go, oops, that disappeared here. We go, well, this line started at the number 3 here on the x-axis. It ended at the number 8. How long is that line? 5. It's 5 long, whatever the units happen to be. Just 5 long. Okay, 5 long. Right? And the up-down line, we should figure out how long it is too. Then you go, okay, it's going up and down. So we go, okay, the up and down, it started at the number 10 here. It ended at the number 20 there. And how long is the up-down line? 10. So it started at 10, ended at 20. It's 10 long. Okay? Now, these 2 lines have names. Right? And you need to know the names. This line that goes left and right is called the run. The line that goes up and down is called our rise. Okay? Our slope, our m value, is given by a very easy to use formula, right? And it goes like this. Our slope is equal to this fraction, right? You have a top number and you have a bottom number. On the top, we put our rise. On the bottom, we put our run. So we just figured out those two numbers. We put those onto our fraction. So our top number is our rise. I like rise is always on the top, right? Just like the word rise means to go up, and the run is 5. So this is our slope. Now our slope is always a fraction, right? And since it's a fraction, we need to simplify our fraction, right? Can 10 over 5 be simplified? Sometimes it can be, sometimes these fractions can't be. Jake, yeah, Jacob.
2 over 5, 2 over 1.
Yeah, this is the same thing as you can divide top and bottom by 5, 2 over 1, which is just 2, right? So now our m value is a 2. So we go back up, we fill in the other two numbers, and our equation is done, right? And y is equal to x plus 4. And we'll do 2 more of these examples, right? So now, the frustrating part, like I said this before, how do I make my triangle? What if I make a bigger triangle? What if I make a smaller triangle than you, Mr. Dhaliwal? Your answer is going to be the same as mine, as long as you read the values right. Because this answer is a fraction. So if you make a bigger triangle than me, you're going to have to just simplify bigger numbers, and you still end up with the 2. If you make a smaller one than me, maybe you have less simplifying to do. It's always going to work out to the same number. Right? We see it's a fraction. You simplify a fraction. That's all you do. Right? And it doesn't matter where you're on this line. Every single triangle on this line has the same steepness. Right? It doesn't matter. As long as you're making a triangle off of this line, it's all going to have the same steepness. So as long as you're reading the values correctly, you'll be good. All right. Tyson, ready? Thank you. So let's try this again. All right? Okay. Y equals mx plus b here. All right? We find our y-intercept first. So looking at this line, Sophia, where is your y-intercept? What number does that line cross the y-axis? Right? What number is it at? No. Here is our line. Here is our y. These two things meet right there. What number is that?
5.
No, one line above 5. 6. It meets right here. This is at the number 6. So our b value is 6. All right? Turn around. That's why I asked you. Turn around. Focus on your nose. Swing your legs. Come on, all the way. All right? Now, the triangle. The one that caused more frustrations. Here's one of my tips for you. This b value that we found, we have to find it no matter what. And it's always usually a nice, easy number to read. So use that as one of your points. You don't have to, but it's usually an easy point to use. So if that's one of my points, now scan this line up and down. So just run your finger up and down this. There's lots of lines, lots of spots where another dot could be placed. Find another spot where a dot could be placed. Does anybody see one? Wants to share their idea? All right? Jacob?
The 6 and 15.
The 6 and 15, where these two things meet, right there. Now, we'll do this, Jacob's idea. If you found a different spot, feel free to use your different spot, right? You'll notice the answers are the same. So with these two dots, we're going to make a triangle. For the bottom one, we stretch out this way. With this one, we drop down. I like to shade it in because it makes it nicer to see the triangle, but you don't have to shade it in. And I'll shade it in. All right? So we need to figure out how long our two lines are. Right? We have our run that goes left and right. This one here, right? It started at this end at the number 0. It ended right here at the number 6. Right? How long is our run? Our 6. All right? Then we do our other line. That one goes up and down. That one's called our rise, like this. Right? And that one started at the bottom here at the number 6 and went all the way up to the number 15 there. How long is our rise? 9. Right? The difference between 15 and 6 is 9. Or 6, right? So now we do our equation. Our slope is our rise is on the top, our run is on the bottom. That means the number 9 goes on the top and the number 6 goes on the bottom. Right? And we look at our fraction here and go, can we make it smaller? If you can, great. If not, we write our answer down as a fraction. Right? Is there any way to make 9 over 6 any smaller? Jacob? 3 over 2. You can divide the top and bottom by 3. And remember, if you're not good at making fractions smaller, that's only like half a mark that you might lose. So you can divide the top and bottom by 3, make it 3 over 2, and just leave this as a fraction. You don't need to turn this into a decimal. Fractions are better for math. So we take this, and instead of m, we put down 3 over 2. And everything else stays the same. So our equation for this line is this thing here. Y is equal to 3 over 2x plus 6. Okay? Two properties, where it crosses the y and the steepness of the line, the slope. All right, last question. Start off with the writing your equation. Y is equal to mx plus b. What is our y-intercept? What is our b value for this one? What number is it? Yes, Lexi. It's right here. Now this question, it's the 10 right there, right? Is a question that commonly teachers put on to confuse students and make sure that they understand this. Sometimes students will give the answer 5. Remember, the b is the y-intercept and not the x-intercept. So sometimes you'll be given a line with 2 intercepts. You got to pick the right one. So always the one that crosses the y. So the y-intercept. And we figured out it's 10. Right? Then we need to get 2 dots on our line. So 1 dot we'll use right here. Then we go up and down this line and trying to find another value that's easy to read somewhere. Right? Do you see another spot somewhere that you can read the value? Right? More than one acceptable answer. Anybody? Suggestion? Lexi?
Are you allowed to use the number 5?
Yeah. Why not make this whole thing into a giant triangle? And it makes it a lot easier to read. So we have this giant triangle now that goes like this. Right? And there's 2 lines. We have our run that goes this way. And we have our rise that goes this way. And this is probably the easiest one to read the values, right? Because it has the number 0 as a starting point for both of them. So our run starts at the number 0, ends at the number 5. How long is our run? Jacob?
Oh, run or goes?
Sorry?
Run or what?
Run.
5.
5, thank you. Our rise starts at 0, ends at 10 here. How long is our rise? Jacob again? 10. Between 0 and 10 is a distance of 10. So we have our slope. Our rise goes on the top, run goes on the bottom. That means it's 10 over 5. Okay? So We have this fraction, 10 over 5. Can it be made any smaller? Reese? 2 over 1, which is just saying 2. So inside of here where we have m, we put the 2 down. And so we have our equation, y is equal to 2x plus 10. Now, based on everything I've told you so far, we've done everything right. But this equation isn't right. There's something missing. There's something wrong with it. Right? I'm hoping you can spot how is this line that we just made different than the other two lines we drew. It's going down. We have to tell, is the steepness going up? Are you walking up the hill or are you walking down the hill? This one is going down. So the slope is going to be a negative number. We use the phrase rise, but sometimes it's a drop. But we use the phrase rise. It's not always going up. Sometimes it's dropping by 10. As we move this way, the line falls. So it goes down by 10. So it goes down by 10. Down. So it becomes negative 2x. Right? So you got to be really careful about that one. Right? Your run, almost always positive. Your rise could be positive or negative. If it's going up, it's positive. If it's dropping, it's negative. And that's it. Okay, for your assignment now, I'm going to make it smaller. The first page, optional. You don't have to do it. It's 3 pages long, right? The first page has nothing to do with day 3. The first page is a review of day 1 and day 2. So if you got time, you can do that. Day 1, day 2. All right. The second page has 6 graphs on it, like we just did. So you have to look at the properties and you have to come up with the equation. And the hard part is picking those 2 dots. And you have to look very carefully. So for example, top one here, we want to find 2 dots where we can read the value. One is right here. The negative 3 is a nice one to read. Then we go up and down this line and you find another spot. And lots of time people want to pick this spot right here. This line here does not cross at 1 and negative 1. Look at it. It's just slightly off. So you have to read a decimal value. Right? So look up and down this line. There will be another spot where it crosses perfectly. And that is right here. So be very careful with your selection. Right? So every single one of these lines will have at least 2 spots where it crosses perfectly, right? There might be more, but at least 2 spots that crosses perfectly. So I'd like you to do these 6 questions on this page, on the second page, and there's 2 questions on the top of the third page. Just like we just did, I made the graph a little bit different looking with more lines, so it makes it a different level of difficulty. Come up with your equation, just like we just did. Question 5 here is optional. This is when I taught Math 10. It's a question almost identical out of grade 10. Right? I've made some minor changes so you guys can do it. But if you want to try, question 5 would be awesome. It talks about, hey, Alex and Zoe both walk from home, and how far away do they meet up? So you have to read it and kind of graph things and figure it out. So a little bit more of a challenging question, but you guys should be able to figure it out. So all of the second page, 6 questions. 2 questions on the third page. I'm also going to give you back your crib sheets that we started last day. Right? So you can add more stuff for day 3 on there too. And I'll put up some of the stuff so you don't forget this over the weekend here. So I'll do that.